All right, again, this is chapter 6.3, graphing radical functions. 5, 6, 7, and 8, I've already explained how to do this with numbers 1 through 4, so I'm really just going to burn through these real quick. So if I were you, I would try them first, see what you can do, and use the videos to check your work. Okay? So here we go. All right, so first things first, it is an even root, therefore this has an endpoint, and the endpoint is at 0, 2. There is nothing being added inside the parentheses, so that's 0, and we're adding 2 on the outside, so that's your y value. All right? If I go to my graph, if I stick this in my calculator and I go to my graph, I've got the points 0, 2, negative 1, 3, and if I scroll up, I get, wow, negative 16, 4. And the next one beyond that is probably something freakishly huge. So we're gonna go with that. 3 to the 4th, actually it's probably 81 or 84 or something like that. So here we go. Your x values go from negative 16 to 0. So I'm gonna put that one way over there. My y's go from 2 to 4. So we've got negative 2, 4, I'm going to count these by 2 again. 2, 4, 6, 8, 10, 12, 14, 16, 1, 2, 3, 4. Negative 1, 3, well that's negative 1, 1, 2, 3. And 2, 0, which will be right there. So this sucker goes up kind of steep and then levels off really fast. It's still going up, but that's what it is. And your domain, all right, your domain and range. So this one starts at 0. Your domain goes left forever from 0, and your range goes up from negative 2. So your domain is from negative infinity to 0, and your range is from negative 2, because that's where it starts, that's the lowest point, up to positive infinity. Okay, and again, if you flip this one over here, go back and fix it. Remember, you got to go negative to positive. All right, number 6, same idea. It is a fifth root. It's an odd root, so this has an inflection point, and the inflection point is at 0, 0. All right, so go ahead and put that in the middle. And it's 0, 0 because nothing is added on the inside and nothing is added on the outside. All right, and as I go through this, the only ones I get are negative 16 and 2 and positive 16 and 2, which, let me check the positive one again. Let me make sure I got that right. I think I did. Yep, I did. Positive 16 and 2, which the next one's down. If it's that far between the first steps, it's way far for the next one. So I'll write this one. In this case, I'm actually going to count by 4s this time. So 4, 8, 12, 16, 1, 2, 0, 0. 4, 8, 12, 16, 1, 2. So, and if you look on your graph, you'll see this one comes in real steep, curves real quick, and then goes out like that. And again, it's an odd root, so it's all real numbers and all real numbers. Okay? Pause the video if you're still copying, but I'm going to move on. Number 7 and number 8. Number 7 and number 8. 7 is still an odd numbered root, so this one has an inflection point. And the inflection point is at negative 3, positive 5. Because we're adding 3 on the inside, everything inside is backwards, and we are subtracting 5 on the adding 5 on the outside. All right. So this one's an inflection point. So I'll do negative 3, 5 in the middle, and then let's get some points. And if you're still wondering how I'm putting this in the calculator, I'm typing it in like this. I'm doing negative 3, parentheses, x plus 3, close parentheses, to the 1 divided by 3. I just do 1 divided by 3. I don't get out the fraction notator, plus 5. That's how I'm putting it in my y equals. And when I go to my table, I get, where am I at? There we go. I get negative 4, 8. I get negative 2, 2. And I might be able to get one really close. Yeah, I get 5, negative 1. And if I go the other way, I probably get one at about negative 10, I'm guessing. Negative 11. Negative 11, 11. So we get some good points on this one. They're nice and close, but that's still my inflection point. So X goes from negative 11 to 5, so I'm going to kind of write it real close. Actually, I'm going to try it right there, so I can count by 2's. And my Y's go from negative 1 to 11, so I'm going to stick that way low. Okay, so if I count by 2's, again I'll count my X's by 2's. I think I can count my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I have to count that by 2's as well. So everything is by 2 this time. All right, so negative 11, positive 11. 2, 4, 6, 8, 10. So negative 11 is right there. 2, 4, 6, 8, 10. So negative 11 is right there in the middle. Negative 11, 11. Negative 4, 8. 2, 4, 2, 4, 8. Negative 3, 5. That's negative 3. 2, 4, 5. Is that right? Something's wrong there. 2, 4, 6, 8. Oh, I know what I did. That one goes there. This one goes here. There we go. Negative 2, that would be right there. And positive 5, negative 1. So 2, 4, 5, negative 1 would go right there. And so this graph comes in at a much slower angle and goes like that. Okay? And it's an odd root, so again, this is all real numbers and all real numbers. Okay? Last but not least, this one has an inflection point because it is an odd numbered root. And it's at 0, 0 as well because there's nothing added or subtracted at the inside. So if we stick this in our calculator real quick, we'll get some points. And there are the points I got from the calculator. And it's even on both sides, so let's do this. Right through the middle. I am going to have to count my x's by 2, but I'm going to count my y's by 1. So that's a 2, and that's a 1. So negative 8, 2. 2, 4, 6, 8, 1, 2. Negative 1, 1. So that's 2 right there. So negative 1, 1. That'll be that guy right there. 0, 0. Positive 1, 1. And positive 8, negative 2. 2, 4, 6, 8. Negative 1, negative 2. That'll be that guy right there. And so this one comes in, goes through there, and back out. And again, the domain and range is all real numbers. And there you go. Easy peasy, chicken greasy.